Hey everybody, I am re-recording my solve for this puzzle here, which is the last gas leak from December. I did originally solve this during the stream. I wasn't particularly happy with both the wording in the rules and generally how the solve went. I went back and I watched Bill, who was the puzzle creator, puzzle setter for this one. He had a solve video, and he kind of explained how the rule set actually worked and his solve path for that. And at the same time, I kind of wanted to do a video showing how a person could potentially logically deduce the correct rule set. So this is what we're going to try to do here. I'm going to try to solve this with kind of taking the mindset as if I was a fresh solver, and we're going to start with the same assumptions that I had when I originally tried to solve this, and then we're going to refute that assumption, and then hopefully logically be able to proceed with the correct solve. Now, it's actually been about 2 weeks since I originally solved this, so I don't even remember a lot of the thing, so that will also help the whole pretending like I never solved this kind of thing as well, since it's been a while since I touched upon this puzzle. All right, so without further ado, let's get into this. It's called half squared Sudoku. Normal Sudoku rules apply, except when they don't. Cells with a bold line running diagonally through them belong to either region they are adjacent to, but not both. Regions they are in is to be determined by the solver. So it's a irregular region 6x6. So each of these regions will still have 1, 2, 3, 4, 5, 6, and every row and column will still have 1, 2, 3, 4, 5, 6. So I think the most logical thing to do to start off with is we'll color the regions that don't involve any of the lines to start with. Let's go with red here, and yellow here, and blue over here. So these are the undisputed regions, right? And because we know every region has to have 6 cells in it, we can fill in this one here for red here. That was yellow. So red here has to take these 3 in order to become a full-fledged region. This one here, we don't know where it goes at all. Well, we know this one doesn't go into yellow, right? So I think we can safely assume it should go into blue, because this one is not touching anything else. And then that leaves only this one for yellow to go out into, and then this leaves only this one for blue to go out to. And then what do we have? Well, we know this one's not orange, so similarly this one should be purple. Then we only need one more for purple, and only need 1, 2, 3, 4, 5, one more for orange. So this one will always be green because neither purple or orange can get to it. So we'll make that one green. 1, 2, 3, 4, 5, 6. Okay. I think that's about as far as we can go with coloring. So let's take a look at the Sudoku now at this point. And we'll see the green 3. The green 3 will have to be here, because I don't think there's anywhere else for 3s to go. And then we have lots of 3s. The yellow 3 will have to go here, and the red 3 will have to go here. And that's all the 3s. 1, 2, 3, 4, 5, 6. Yep. Okay, now we look at the 4s, which are the other kind of weak digit we got here. 4, 4. This is a 4. We already got a purple 4. So now we need an orange 4. Orange 4 has to go right here. So this is the orange. This one will have to be green then. And green will also have to go out here, and this will be purple, right? But now we run into an issue. We run into an issue because where does the green 4 go? And we say, uh-oh, something's wrong. Something went wrong at this point. And so we backtrack, right? We backtrack, and we start thinking, okay, well, how do we resolve this, right? Maybe what we'll do is we'll go all the way back to the point where we were starting to color in these region stuff. Okay, and we'll just do the Sudoku at this point here. And we'll use the combination of Sudoku, and then we'll reapproach the coloring and see if that helps anything. Because I think, looking at this, I still think we need a 3 right here. Let's just make sure. Let's take a look at that. All colored in. Okay. So we might have to do a little bit of combination of the two. Yeah. Okay. Let's color at least this one. I think for sure we know this one has got to be red, right? And then this cuts that. We know 3s are in here somewhere from that. I think we can safely assume this one's going to be blue and this one is going to be purple. Because I don't see... Problem is, this could totally... 1, 2, 3, 4, 5. Okay, so here's the thing, right? If we are... What I'm thinking about right now is that there's nothing in the rules that state that the regions have to be orthogonally connected, right? It doesn't say that they cannot be. It doesn't clarify that. But it doesn't explicitly state that they are connected either, right? It just says that these are, they can belong to any regions that are adjacent to them. So that includes diagonally adjacent. So if I was to color all these green, for example, this would work. 1, 2, 3, 4, 5, 6. But then this one could get out this way, hey? This could be a purple like that. I was trying to argue that this had to be purple, but the thingy thing really thinks our thing. And similarly, this green can also touch this one. This one might be more of an issue though, right? Because now this yellow is completely boxed in. Oh, unless, well, even if we do this and let the yellow out, now the blue is boxed in. And there's no way for this blue to get out. So so for sure, this cannot be green. So this one must be blue. Okay, so we can do that one at least. And then one of these is going to be yellow. One of these is going to be yellow. Okay, so with that noted, we can write this one in as 4. And then we're missing a 4 here, which has to be right here. And then our last 4 has to be here. So we know this is not going to be purple. Orange still needs a 4. 1, 2, 3, 1, 2, 3, 4, 5. It can't grab this one, so it has to grab this one. Okay, blue already has a 4. Yellow already has a 4. So this 4, therefore, must belong to green. Okay? So now, where does blue go? Blue has to come out over here. So this is either going to be yellow or blue. And then green. Orange can't take anything else, right? 1, 2, 3, 4, 5, 6. So if purple goes here, then green is completely stuck. So green has to take this one and this one. And then these ones must be purple. Okay, so I think we've got it almost all colored except for these two, which we don't really know. So now we can go back and we can do some of that Sudokuing. So where does these 3s go? 3, 3, this one must be the 3. So now this must be 3. I think that's all 3s again. Oh, there. Okay, so that's all the 3s. And then might as well just start pencil marking the rest of this. This can't be a 2. Interesting thing to note, this square sees everything in here. It's not a 4. So this square and this square, they must be the same cell, so or same number. So we're gonna just mark that as an A for now, just so we know. This is also a 1, 2. This is a 1, 2, 5. Except that's not a 2. This one can be 2, 5, or 6, except for you. You are only a 5 or 6. That's also a 5, 6. This is not a 5. 5, 6, and a 2, one of which must be a 2. This is a 1, 5, or 6. One of these is a 1. We've got a X-wing on 1s here, so this cannot be a 1 anymore. The 1 must be in here somewhere. What do we have here? This is 1, 2, 5, 6. These can't be 5s, so these two must be 5s. And there. Okay. Then what are we left with here? This is 1, 2, and 6. This is 1, 2, 5, 6. Lots of possibilities. This one is 1, 5, and 6. This one cannot be a 5 because of this one right here. Which means this is also only a 1 or 6 because they are the same number after all. Okay, and so here we reach kind of a conundrum, right? Because if we were to just arbitrarily plug in, for example, let's just plug in a 6 in here and says this is 6, this is 6, this is 1, right? This cannot be a 6, this cannot be a 6, this is not a 6. We're gonna run this one through, and then this one's not a 5 either, actually, it's a 2. 2 there. Longer 1. Guess we'll ask ourselves a question at this point. Where do these go, right? Because if this was to go into yellow, if this was to go into blue, then this one must be a 2. This would be a 5. This would be a 1. And then this would be a 5 again. Well, 2 5s here. So this cannot go into blue. So this would have to be a yellow in this case. This will have to be yellow, and this one will have to be blue. So now we can get rid of the 6 in here. This is a 1 5 pair within that blue. So that must be a 2. That's a 6. 6 sees this one here, which sees all these things. Boom. And you see this all resolves. And I think this meets pretty much all the rules, but we didn't get the, hey, you did it type of thing, because it doesn't actually match the solution that Bill had. And so we're gonna go back, right? I'm gonna try the other possibility. So we tried 6 in our little A slot, right? We're gonna go all the way back, and we're gonna try 1 this time. We try 1 this time. Let's put 5 here. This will be a 6 now. This, actually, we don't know where it goes, but that one can't be a 6. Also can't be a 5, so that's a 2. This is a 6, and then now we know this cannot be in blue. So this one must go into yellow. This the other way, the other color. Now we're going the other way. Because before this was a yellow, and this one is a blue, and now we're flipping it the other way. 5, 6, 5. This is a 2 again. I think either way it was always going to be a 2. 5 is what are we left with? A 2 and a 6. And now we get the little, hey, you solved it, correct thing. So both of them does resolve, and I did double check both answers. They both make sense within the confines of the rule. I think the only hint that we get for disambiguating which is the actual correct way might have to do with how the diagonal lines go. Where this one's kind of going, you know, says that, hey, you can go to this region or that region maybe. Or this one go to this region, this region. I don't like looking at it that way. I think realistically it could have gone either way, and the lines were probably just drawn so that you don't get to a parallel line in the middle of nowhere. It's just way it will actually connect all the diagonals together. But I think that's the only hint that we really have, that this belonged to blue versus going towards yellow. Otherwise, yeah, I think both solutions does work, whether this is a 1 or a 6. Because as you can see here, right, every other number is actually exactly the same. The only thing we could do is we switch these around and we switch the coloring of this, and it still resolves completely. So it's a deadly pattern in a weird way as well. Anyways, that is my take on this one. It's still a great puzzle. It's just the rule sets needed to be cleared up a little bit. I think that definitely led to some confusion for a lot of people. I hope this one walks you guys through it a little bit better. And yeah, if you guys enjoy these videos, please leave a like, leave a comment. I love reading the comments, as I mentioned before. It keeps me motivated to continue making these videos. Until next time, thanks for watching. Ciao.